Welcome back to CSConnect series. From this video, we are starting number systems. In number systems, the first content that we will be discussing in this video, it will be number base. So what is called a base of a number? So the other term for base is radix. So when they say radix of a number or base of a number, both are same. How to understand this number base concept? Let's take a number 7239. How do you write this in words? When you write 7239 in words, it will be 7239. Let me interpret this in place values. 7 is placed under 1000th value, 2 is placed under 100th value, 3 is placed under 10 and 9 is placed under 1 or unit position. Now you can find every place value is holding a digit and that digit is alone together taken to be a number. You have to represent 1, 10, 100, 1000 using the same value. In what way can you represent the place values using the same number? Thousands, hundreds, tens and ones can be represented using 10 power. So when it is 10 power 0, we can equate it to 1. When it is 10 power 1, we can equate it to 10. When it is 10 power 2, we can equate it to 100. When it is 10 power 3, we can equate it to 1000. Now we will just represent the number 7239 along with the 10 powers. So 7 into 10 to the power 3 will give you 7000. 2 into 10 to the power 2 will give you 200. 3 into 10 to the power 1 will give you 30. And 9 into 10 to the power 0 will give you 9. When you add up these numbers, you will get 7239 ultimately. Every digit here is expressed in the form of 10 powers. So we call 10 to be the base of our decimal number system. So the number system that we use in maths, 0 to 9 number system is called as decimal number system and it belongs to base 10 because there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any digit we form belong to these 10 digits only. This decimal number system, we call it as base 10 system. This particular row is written in the format of coefficients into base 10. So this base 10 part is expressed as 10 power 0, 10 power 1, 10 power 2 and 10 power 3. And the coefficients are nothing but the numbers accompanying the base. Here the coefficients are 7, 2, 3, 9. So only the coefficients are written together to represent a number. How do we actually read this number? We don't read it as 7239. When we want to express it with a value, we tell 7239. This 7 into 10 to the power 3 we have just expressed, right? That is written in the general format. It is given in the form of an and r power n. Now we will just continue with the previous example. We have mentioned that 7 into 10 to the power 3, 2 into 10 to the power 2, 3 into 10 to the power 1 and 9 into 10 to the power 0 for the number 7239. Let's interpret. Here the coefficient is 7 in thousands place, 2 in hundreds place, 3 in tens place and 9 in units place. A3, A2, A1, A0 are just taken and the base form 10 power 3, 10 power 2, 10 power 1 and 10 power 0 is equated to r power 3, r power 2, r power 1 and r power 0. A3 into r power 3. This will give 7 into 10 to the power 3. This is what is represented in this row. So A2 r power 2 is 2 into 10 to the power 2, A1 r power 1 is 3 into 10 to the power 1, A0 r power 0 is 9 into 10 to the power 0. So while writing the number, we write the coefficient in this form. So we start from right side and move towards left, A0, A1, A2 and A3. So we are writing the coefficients as a number without including the base. Now let's take the general form again. What about numbers represented using decimal points? We'll take a number now, 7239.5. How are we going to represent this? 7239 is what we saw earlier and now the decimal point is here. After the decimal point, the representation goes to minus pass. It means r power minus 1, r power minus 2, r power minus 3. It starts from here. And before that you have r power 0, r power 1, r power 2, r power 3. After the decimal point it goes from left to right, and before the decimal point it goes from right to left. Now what is 5 into 10 to the power minus 1? Usually we represent 10 to the power minus 1 as 1 by 10. This can be also taken as 1 by 10 power 1. So when it goes to the numerator, this becomes 10 to the power minus 1. So what is 5 into 10 to the power minus 1? It is 5 into 1 by 10, which is equal to 5 by 10. So when you cancel it, it becomes 1 by 2. Even when you don't cancel it, you just divide 5 by 10, you get 0.5. Now when you add this 7000 plus 200 plus 30 plus 9, you get 7239. Along that you have to add this 0.5 also. When you add them together, you will end up with the number again. Now we will see the interpretation as per the format. So A3 is 7, A2 is 2, A1 is 3 and A0 is 9 as per the example. And now we get a new coefficient A minus 1. So this is equating to 5 and the corresponding base power will be 10 to the power minus 1, which is equal to 1 by 10. So when we have 10 to the power minus 2, this becomes 1 by 100. The other way we can represent is 10 to the power 2 in the denominator. Now we are writing it again in the format along with the decimal notation. We are starting from right to left for before the decimal point, and after the decimal point we move from left to right. So when you have another point, say for example if I say 0.56, this will be a minus 1 and this will be a minus 2, and so this will be r power minus 1 and this will be r power minus 2. It goes on this way, so you should remember that. So now you could have understood what is a base of a number. It is with what value we specify and how the weightage is given to every digit. The weightage depends on the particular base. This is for the normal decimal number system that we use. In computers, along with these number systems, we have other number systems too. So under digital electronics, we have the topic number systems. In that we have 4 number systems: decimal, binary, octal and hexadecimal. So decimal is base 10, binary is base 2, octal is base 8, hexadecimal is base 16. All these 4 number systems can be placed under the topic binary systems. Every number system can be expressed in every other number system. Now we will understand what are decimal numbers. Though we know already, we will see it in the context of base. So decimal number is base 10. It has 10 digits. The digit has to start from 0 and then goes like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now how will you represent 10 here? We will have 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be repeating with 1 in the first position. After 19 you will have 20. So 21, 22, 23, 24, 25, 26, 27, 28 and 29. Here 2 will be coming in the first position and 0 to 9 will be repeating. Similarly, you will have 3 in the first position from 0 to 9. This will be 30 to 39. If we have 6 in the first position and have 0 to 9, then we will have 60 to 69. Similarly, if you take 9, the last digit in the first position, then 0 to 9 in the second position, you will have 90 to 99. Now you have 99 digits here. After 99, the next digit will be 100. How will you place that? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 we had 10, right? So we will place 10 here. This becomes 100, 101, 102, 103, 104, 105. How do we frame this? We are placing 2 zeros here and the 1 is getting placed here. So for 10 we are placing 1 0 and starting with 1. Now we have to place 2 zeros and start with 1. So again till 999 this will be very smooth. Again for the fourth digit we will place 3 zeros and then start with 1. So this will end up with 4 9s altogether. This goes on like that. So the 2 digit is formed by placing one digit fixed and the other digit will run from 0 to 9 altogether. Why do I remind you how to write 2 digit, 3 digit number is, this is how you will be working with the other bases too. So only when you are strong with decimal base, I can easily repeat the same thing for other base. So let's take the 2 digit number. We are writing it as 10, 11 and 12. As per base, how can we interpret this? We can interpret this in forms of 10 power. Say for example, 10 can be taken as 10 power 0 and 10 power 1. So 0 into 10 power 0 is 0 plus 1 into 10 power 1 is 10. So this is equal to 10. Now for 11, this is 10 power 1, this is 10 power 0. We have 1 here, 1 here. This will give a value of 10 and this will give a value of 1. When you add, you get 11. Now again you see for 12. 1 into 10 to the power 1 is 10 plus 2 into 10 to the power 0 is 2 into 1 which is equal to 2. So this will give you 12. Though we know how to write 10, 11, 12, that's not the issue. It's about how you expand this and understand the base concept. Now we'll get on to 3 digit numbers. So we have 10 power 2, 10 power 1 and 10 power 0. Then we are starting 0, 1, 2, 3, 4, 5 up to 9. Then we will change this part. So for every number we will have 0 to 9. For this number we will have 0 to 9. For this number we will have 0 to 9. So if it's 1000, this will start 0, 1, 2, 3. Then it will come here. Then it will come here. You have to use all till 999 and this is how it happens. Now let's go for 4 digit numbers. This is having 10 power 3, this is having 10 power 2, this is having 10 power 1 and this is having 10 power 0. I am just telling you how to expand these numbers as powers, only then it will be easy for you to understand the other bases. Now we will move on to binary numbers. Binary in the sense we have only 2 digits, 0 and 1. So this belongs to base 2 and any digit will be formed only using these 2 digits. We will start with 0 and 1. We will basically start with 0 and 0 here. 0, 0 is equal to 0, 0, 1 is equal to 1. When you want to write the next digit, obviously you will place 1 here and then write 0, 1 here. So 1, 0 will be 2 and 1, 1 will be 3. When you want to write 4, this 1 is over, right? Now you have to start with 0 again in both the places. Then 1 will be placed in the third position. So what are the combinations of 0, 0? We have 0, 0, 0, 1, 1, 0, 1, 1. We have 4 combinations. Everything will have 1 here. So this will become 4, this will become 5, this will become 6, this will become 7. So we will see for 0, 1, 2, 3 first. 2 power 0 is 1, 2 power 1 is 2. If 2 has 0 and 1 has 0, 0 plus 0 will give you 0. Now here 2 into 0 is 0, 1 into 1 is 1, 0 plus 1 will give you 1. Now 2 into 1, this 2 into 1 will give you 2 and this 1 into 0 will give you 0. 2 plus 0 is equal to 2. You have 2 into 1, 2 here and 1 into 1 as 1 here. 2 plus 1 will give you 3 here. This is how it has to be expanded. Now coming to 3 digits. All these will be prefixed by 0. Now they are prefixed by 1 altogether and we have 0, 0, 0, 1, 1, 0, 1, 1. Another way we can find them is 2 power 2 is 4, 2 power 1 is 2, 2 power 0 is 1. Where do we have 4? We have here. So place only 1 here. Rest of the places will have 0. Now this is equal to 4. Now what combo will give you 5? 4 plus 1 will give you 5. Just place 1 in those 2 places. That will be 5's representation. For 6, 4 plus 2 is 6. So we have 2 ones in 4 in 2's places. This is 6. For 7 it is 4 plus 2 plus 1. So all the 3 places are having 1. Then for the 4 digit numbers. So from 8 till 15 you will be representing using 4 digit number. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So till 15th value you can place it. What about 16? There will be a column called 2 power 4 which is equal to 16. We will place only 1 here. The rest of the boxes will turn as 0. The next number system that we are going to see is octal. So octal is base 8. Once we say it has 8 digits, it means it starts from 0 and ends with 7. Any number that has 8 or 9 will not be octal. So when they ask a particular number is octal or not, you need not calculate anything. Just check whether all the numbers fall in this range. If they are in this range, then it's octal. Any octal number will be formed only from these 8 digits. Now, how will we write the next set of digits? So, let's take 0, 1, 2, 3, 4, 5, 6, 7. The next set of digits will be written using 1. So, have 1 here and repeat 0, 1, 2, 3, 4, 5, 6, 7. What is the next digit? It is 2. So, write 2. Then write 0, 1, 2, 3, 4, 5, 6, 7. So everything will have 2 in prefix. Till what you can go till 7. 70, 71, 72, 73, 74, 75, 76 and 77. After 77, you should start with 100. Make these two positions 0 and start with 1. So it starts from 100 and goes till 700 and ends till 777. Why are these octal systems there? They are used actually to interpret large binary numbers in computer languages. So imagine there are lots of 0, 1, 0, 1, 0, 1. Computers can understand every zeros and ones. But for humans to enter information or represent something, we may not be comfortable with so long binary numbers. So for our sophistication, these octal numbers and the next hexadecimal numbers will be used. So just to interpret large binary numbers in computer languages, we are using octal and hexadecimal numbers. So let's take the 2 digit. So if it is base 8, we will have 8 power 0, 8 power 1, 8 power 2, 8 power 3. Similar to base 10 and base 2. So now you can see if 7 is this number, then 8 will be 10, 9 will be 11. That's what is given as 10 in 8. Then for 15. So this is 10, 11, 12, 13, 14, 15. This will be 15 equivalent. And so we have 1 and 7 here. Then for 63, 7 into 8 power 1 is 7 into 8, which is equal to 56. And 7 into 1 is 7. So multiply these two and these two. Just add, you will get 63. This is how we will be expanding octal. Now 3 digit numbers. We have 8 power 2, 8 power 1, 8 power 0. So when I say it's 64, I have 64 as a whole. So I am keeping 1 here. The rest of the places are 0. Now just interpret 71. 1 into 64 plus 7 into 1 equal to 7. And this is 64 plus 7 is equal to 71. Now 7 into 64 will give 448. Then 7 into 8 will give you 56. 7 into 1 will give you 7. Altogether, you will get 511. So, 777 is equal to 511. Now, we will go for 4 digits. It starts from 512. 8 to the power 3. It's 8 into 8 into 8. And they have given a representation with 4 sevens. What are 3 sevens? It is 511. So, what is the 4th 7? It is 5112 into 7. We will have 3584. So what is 3584 plus 511? It is 4095. Now we will move on to hexadecimal numbers. Hexadecimal numbers have a base of 16. In that the first 10 digits are from decimal. So 0 to 9. So from the number 10 we will be using letters. So 10 is represented as A, 11 as B, 12 as C, 13 as D, 14 as E and 15 as F. So when you find any numbers like 6AF or 6DE, 71F, all these are hexadecimal representations. For that, don't have TUV as a representation and say it's hexadecimal. It should have only these 6 letters. The digits should be from 0 to 9. So this is how we will be writing hexadecimal number from these 16 digits. 10 from decimal and 6 from letters. So this is 0 to 15. What about 16? So 0 to 15 will be 16 to 31. Then 0 to 15 will be 32 to 47. So when we say it is 10, it is 16. When we say it is 20, it is 32. So these systems were also introduced to interpret large binary numbers in computer languages. In fact, computers' memory location are usually represented using hexadecimal numbers for our own understanding. Now let's see the example. 16 power 0 and 16 power 1. So for 3 digits we'll have 16 power 2. For 4 digits we'll have 16 power 3. Just as we did for base 10, the same thing will be done here also. So here 16 is what we saw as 1 0. When you interpret this, this is 1 into 16 plus 1 into 0, which is equal to 16. Taking 17. 1 into 16 is 16, 1 into 1 is 1, 16 plus 1 is equal to 17. Now they have given us FF. What is F? F is 15. So 15 into 16 it's 240 and 15 into 1 will be 15 here. 240 plus 15 will give 255. Now we'll move on to 3 digit. We know this is 255 and this is 15 into 256. So you have to add together, you will get 4095. Now we will go for 4 digits. Triple F is 4095 and 1 into 4096. When you add them, you will get 8191. That is what is given here. So this is 4096 plus the 4095 value from this table. So this is how you will be expanding and interpreting the digits. Now we will get on to the practice problems. These are the kinds of problems you might get when you are dealing with number base. So let's get into a basic problem. How do you represent the numbers 0 to 15 in base 12? When you take base 12, we include numbers from 0 to 9. Then we have 10 and 11. So whenever 10 and 11 are there, you are not supposed to represent this way, because when it goes to 2 digit, the base will be applied automatically. So represent 10 by A and 11 by B, that will be correct. So 0 to 11 will be represented as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A and B. Now when you want to take the values of 12, 13, 14, 15, the units digit has to be repeated. So we will repeat 0, 1, 2, 3, 4, 5. All this can be prefixed by zeros. So once the order is over by 0, the next number that takes position will be 1. So just place 1 everywhere. So now what are the numbers they are asking? They are asking from 0 to 15. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. Then we have 1, 0, 1, 1, 1, 2 and 1, 3. So this stands for 10, 11, 12, 13, 14, 15. So this is how we will be writing. Once you have 2 digits in base number, you will automatically get into this power conversion. That's why we are using A and B notation. Now we will just expand it and check. So 1 into 12 to the power 1 is equal to 12. 0 into 12 to the power 0 is 0. So overall we get 12. For 13, this makes 12 and 1 into 12 to the power 0 is 1. So we have 12 plus 1 is equal to 13. For 14 we have the same case. Here it is 2. Then for 15 we have the same case here, and here it is 3. Next question. Determine the value of base B if 211 base B is equal to 152 base 8. Now how will you interpret this 152 base 8? So it has to be taken as 8 power 0, 8 power 1 and 8 power 2. This will be 1 into 8 power 2. So this is 1 into 64 plus 5 into 8 power 1 is 5 into 8 plus 2 into 8 power 0 is 2 into 1. So always start with 8 power 0, 8 power 1 and 8 power 2. We are just expanding it because it is of base 8. 1 into 64 is 64 plus 5 into 8 is 40 plus 2 into 1 is 2. 64 plus 42. So this is 64, this is 42. We have 106. Decimal equivalent will be 106. Now we have to interpret using base B. They have not given what number it is, but we have to find it. So this is b power 0, this is b power 1 and this is b power 2. 2 into b power 2, it is 2b square plus 1 into b power 1 is b plus 1 into b power 0 is 1. Now they have said this part is equivalent to this part, that is LHS is equal to RHS. So 211 base b is equal to 152 base 8. This will be 2b square plus b plus 1. This is equal to 106. When you solve this equation, you will get the value of b. Mathematically, if I want to solve this and take some value outside, I am going to use 15b minus 14b to make it plus b. So 15b minus 14b will be 1b, which is equal to b. Why do I do this work? I will tell you. This is equal to 106. 2b square plus 15b minus 14b. When you bring 106 this side, this becomes 1 minus 106, which is equal to minus 105 is equal to 0. Now just take b outside from this. This is 2b plus 15. This is 7 into 2 and this is 7 into 15. So let me take 7 from this, and this is again 2b plus 15, which is equal to 0. This equation can be solved like this. From here I can conclude b is equal to 7. Now just substitute 2b square plus b plus 1. So when b is equal to 7, we have 2 into 49. 7 square is 49. And we have b, so 7 plus 1. 2 into 49 is 98 plus 7 plus 1. This will give 105 plus 1, 106. We are getting the number correctly. So we can say b is equal to 7, the right answer. This is the usual way to solve. But in examination point of view, you need not go for this step at all. You will have 2b square plus b plus 1 is equal to 106. Usually in exams, they will give you some options. Now the work that you have to do is, you have to substitute b is equal to 6. Find the answer. Then go for b is equal to 5. Find the answer. B is equal to 7. We know the answer is 106. For b is equal to 9, you have to find the answer and just conclude it. You need not go for this mathematical way and all. When they are asking in descriptive form, of course you have to find it using this method. But when you are attending objective kind of examination, your options will save your time. So let's check. B is equal to 6. 2 into 36 plus 6 plus 1. 72 plus 7 is equal to 79. It is not equating. Then 2 into b square is 25. Plus 5 plus 1. So 50 plus 6 will give 56, which is not equating. Then 2 into 9 square is 81 plus 9 plus 1, which is equal to 162 plus 10, which is equal to 172. So this is also not equating. So from here also we can say b is equal to 7. The next question, the solutions to the quadratic equation x square minus 11x plus 22 is equal to 0 are x is equal to 3 and x is equal to 6. What is the base of the numbers? The values of x are given in the question. It means you have to work with the coefficients in order to find the base. How do you find the coefficients here? First we have to interpret this particular equation in the form of x bar 0, x bar 1 and x bar 2. X bar 1 can be taken as x and x bar 0 can be taken as 1. The coefficient of x bar 0 is 22. So 22 into 1 will give you 22 again. What about this minus 11x? X power 1 is having the coefficient of minus 11. So minus 11 into x power 1 can be written as minus 11 into x. What about x square? When you don't have any other number in front of x square, this is equal to 1 into x square. So 1 into x square will be x square only. Now we have to apply base to this coefficient that is present before the power of x. X square can be taken as 1 into x square, which is actually having the coefficient of 1. So taking 1 to be the coefficient, we are going to apply the base only to this coefficient. We are not going to take the minus here, only the 11 we are going to consider as of now. For x power 1 we are having a coefficient of 11. This 1 coefficient can be applied to the base. Into x will be treated as it is. Since x power 0 is equal to 1, we will just leave it. This 2 is again the coefficient part. So the 2 part can be written along with the base. When you have a 2-digit coefficient with a base b, let's take the coefficient to be mn to the base b. How will you expand this? N into b power 0 plus m into b power 1. This is the way we will be expanding. So the unit digit will be applied to b power 0 and the test digit will be applied to the b power 1. Similarly, we are doing here. Since only 1 is present, the first power will be b power 0. So 1 into b power 0 into x square will stay as it is. Regarding 11 to the base b, we can split it as 1 into b power 0 plus 1 into b power 1. Regarding 2 to the base b, this 2 will have 2 into b power 0 and this 2 will have 2 into b power 1. This is how we will be expanding the coefficients. We have to work only with the coefficients of x degree. 1 into b power 0 is equal to 1 into 1 which is equal to 1. So we can retain the x square as it is. What is 1 into b power 1? It is b. 1 into b power 0 is again 1 into 1 which is equal to 1. This will be b plus 1 into the x will be retained as it is. 2 into b power 1 is 2b. 2 into b power 0 is 2 into 1 which is equal to 2. What is the equation given in the question? X square minus 11x plus 22 is equal to 0. X square is not going to have any change because the coefficient is 1. We will have x square as it is. We will place the minus here. Instead of 11 to the base b, we got b plus 1 into x. So 11 to the base b has changed to b plus 1. This x will be retained as it is. Plus, what did we get instead of 2 to the base b? We got 2b plus 2. So we are placing 2b plus 2 as it is and equate it to 0 here. This is the equation we have got. Now we will solve this equation. X square minus, we have to apply this x inside. So this will be x into b plus x. Then this plus will be as it is. Then we have 2b plus 2 which is equal to 0. Now we have to apply this minus inside the brackets. X square minus xb minus x. Then we will place the term as it is 2b plus 2 which is equal to 0. We have to first apply x is equal to 3 in this equation. So the equation is x square minus xb minus x plus 2b plus 2 is equal to 0. This is 3 square minus 3 into b minus 3 plus 2b plus 2. This is equal to 0. What is 3 square? It is 9. What is minus 3b plus 2b? It is minus b. What is minus 3 plus 2? It is minus 1 which is equal to 0. Now this can be taken as 9 minus 1 is 8. 8 minus b is equal to 0. From this we can take the value of b is equal to 8. It means the base of the number is 8. Now what about x is equal to 6? Let's apply the value of x to the same equation again. 6 square minus 6b minus 6 plus 2b plus 2 is equal to 0. 6 square is 36. What is minus 6b plus 2b? It is minus 4b. What is minus 6 plus 2? It is minus 4 which is equal to 0. 36 minus 4 will be 32 minus 4b which is equal to 0. From here we can rewrite this as 4b is equal to 32. Minus 4b will go to this side and this will turn to 32 is equal to 4b. So I am writing it in this way. From this we can take b is equal to 32 divided by 4 which will equate b to the value of 8. So here also we get b is equal to 8. It means you can either substitute this value or this value. Whichever value you substitute, you will get the same base value here. This is how you will be calculating the base when a quadratic equation is given. Remember one thing, you have to apply base to the coefficients of the degree here. Next question, Determine the base of the number 302 by 20 is equal to 12.1. You have to write the number like this. 302 to the base b divided by 20 to the base b, which is equal to 12.1 to the base b. Now how will you write 302 base? This is 2 into b power 0 plus 0 into b power 1 plus 3 into b power 2. So this is 3b square plus 0 plus 2 into 1, it is 2. So we can write this as 3b square plus 2. So this is 3b square plus 2 divided by. So next we have to write 20 to the base b. So this is 0 into b power 0 plus 2 into b power 1. This is equal to 2b plus 0, which is equal to 2b. So we have 2b here, which is equal to 12.1. So 12.1 to the base b. Not necessarily you have to go with base b. You can use base r, you can use base x, any number, but make sure you know which notation you are using. So 12.1 can be written as 2 into b power 0 plus 1 into b power 1. So after the decimal point, you have to use minus part. So just add a plus here. It is 1 into b power minus 1. So 1 into b power 1 is 1 into b, which is equal to b. Plus 2 into b power 0 is 1. So 2 into 1 is 2. Plus 1 into b power minus 1 is 1 by b. This is the equation on the right. So b plus 2 plus 1 by b. We will split the numerator into 2. So this is like a plus b divided by 2. We can write this as a by 2 plus b by 2. Similarly, we will write it as 3b square by 2b plus 2 by 2b, which is equal to b plus 2 plus 1 by b. Now I can strike out 1b here. See, b square is b into b, and here I have 1b in the denominator. So I am striking it out and taking only 1b in the numerator. So this is 3 by 2b plus I can cancel 2 and 2 here. This is 1 by b, which is equal to b plus 2 plus 1 by b. I have 1 by b here. When I bring to the other side, both will get cancelled. Now the final equation is 3b is equal to b plus 2. So the denominator will move to the numerator, which is equal to 2b plus 4. So now 3b is equal to 2b plus 4. So b is equal to 4. The base of the particular equation is 4. This is the answer. Determine the base of the number 24 plus 17 is equal to 40. This time we will solve it using x. So let's have 24 to the base x plus 17 to the base x is equal to 40 to the base x. So this is 2 into x power 1 plus 4 into x power 0 plus 1 into x power 1 plus 7 into x power 0, which is equal to 4 into x power 1 plus 0 into x power 0. So 2 into x power 1 is 2x and 4 into x power 0 is 4 plus 1 into x power 1 is x plus 7 into x power 0 is 1, so 7, which is equal to 4 into x, 4x plus 0 is there, so we will just leave it off. Now 2x plus x will give 3x and 4 plus 7 will give you 11, which is equal to 4x. Keeping 11 this side, I am taking 3x to that side. So this means x is equal to 11. Overall, these are the different kinds of problem available in finding the base of a number. We are completing the base of a number video with this. I'll meet you in the next video. Thank you, viewers.